morning. My name is Raju Mariyappan. I'm Director of Asset Digitalization and Reliability. Basically, today I'm going to talk about my experience, in this Industry 4.0 journey, where we started, where we are right now, where we are going to, where we want to head. So, production.
Lower this a little bit for you. Be more comfortable.
Thank you. So, production is one of the main KPIs for any manufacturing industry. So, to attain that production, there is a lot of day-to-day challenges, firefighting, and assumptions, a lot of subjectivity. As per me, it's working good. As per me, it's not working good. So, shift A is working fine. Shift B is not working fine. There's a lot of assumptions. There is no really what is going on in the background. We all do that firefighting every day to achieve that production. So that's where we thought of collecting the data and provide some more visibility to plant teams, where they can make some data-driven decisions. Even if it is some problems happening, at least they should know what exactly happening in that component, so that they can make some good decisions based out of it, right? So that's where we started working on data collection, and the journey was not that easy. There's a lot of challenges in when we started this journey. There are different types of sources for the data, sensors, nodes, controllers, PLCs, different communication protocols. There's so many things, data is scattered everywhere. We want to bring it to one platform where we can do all the analytics and provide visibility to the plant teams. And the corporate side, we have IT, OT, and always there is a kind of challenging, what we want for industry and what IT thinks is best for the industry. There is always kind of challenging, to communicate to them. And also, we have a planning team also. There is also another challenge, how we can communicate the manufacturing information to planning, so that they can make better planning for the production. So that's another challenge. And when we're looking at the tools, the scalability, horizontal and vertical, how many plants we can roll out, how many areas we can cover within the time frame what we have. So those are the challenges we faced in the initially, when we started this journey. We choose edge computing. Edge computing enabled us to communicate with all the devices, all the sources of data. Right now we connect to sensors, nodes, controllers, we name it. We connect to every single device at shop floor to collect the data. And we do analytics at edge itself. We do all the heavy lifting on edge, and we send notifications, alert modules, everything at edge itself. And silo-wise, it's a completely kind of self-service kind of tool. Nothing much. We can easily drag and drop and build that correlations, logics, and when we do this analysis and all. So that gives a lot of freedom for us to work on different areas, different use cases. And scalability-wise, again, it's so many. As of now, we are collecting almost 20,000 data points per hour. And we are processing it, analyzing it, and we are sending notifications alert based on the thresholds and statistical model we have. And we do have few predictive models as well. So scalability-wise, edge computing system is enabling us to do whatever we want with complete freedom. Few use cases I want to talk about. Basically, as I mentioned, we are collecting 20,000 different data points every hour, and every data point is monitored separately, and there is an alert notification system for that. We have thresholds, we have statistical models. Few of them is we have predicting models also. So we let people, plant team know what is going to happen in next 6 hours. So that's what the capability of edge computing system, so that plant team can decide what they want to do. Either they want to postpone it, or they want to fix it right away. They can make a data-driven decision. And parallelly, we are sharing that information with the planning team. This mission is going to go down in next 6 hours, and this is the duration of that downtime. Then planning will make an action, like, maybe we can divert that production to some other location, or like, they can make some better planning on that as well. So few other areas with all these assumptions, like, we have, every human has like, limitations, right? When you test the equipment, there is a limitation. I can share one of the experience at one of my plant. So we started with the handheld device, like, to check the vibration. So everybody goes out of the field, like, we have almost like 130 motors in each line. We have over like, more than 120 lines. So the first thing is like time consuming, going to every motor and like, listen to the vibration. And after 10 motors, all the vibration noise looks same. Like there is no way like, we can differentiate. That's the limitations we have. That's where the digital transformation, like, this edge computing system comes in picture and evaluates that data, provides that clear information, like, what exactly happening within the system, so that like, we can make some decisions out of it. So we started with replacing motors, like, in the beginning. If anything goes wrong, like, we just replace it. We used to have contractors. We spend a lot of money on it. Now, even if, even other side, like, there are some OEM recommendations. Every year we have to replace this bearing. We don't know it's good, bad, but it's an OEM recommendation. We need to replace it. So with this system, what we are doing is like, we are providing the information, like, the condition of that specific component, so that like, whether it is need to be replaced, or like, we can push further, like, 3 months, 6 months. We have good success in this area. We used to have annual rebuilds, like, every 12 months we used to rebuild. Now we pushed that to 18 months. Like, we don't know where, like, how much we can, how far we can go, but for now we are pushing 12 months to 18 months and see, like, what exactly happening. Since we know the condition, we can make a decision, like, not any given point. If something breaks, we can go back to 12 months. If it is not, still we can push it. And also we are working on some prescriptive maintenance analysis. Basically, whatever we predict, like, for example, this motor is going to go down after 3 months. What we can do today to eliminate that, right? So that's a prescriptive model we are developing. It's working fine. And one of our vision is like, lights off plants. Most of you guys are heard about that. So all our utilities area, like, completely digitalized. Almost 20, we have 45 plants in US. 25 plants, we are completely digitalized as of now. And utility is like, completely like lights off. No person needed, system is monitoring continuously. Every 5 minutes, like, we collect the data, we analyze the data. System is working on the real-time monitoring, and like, we send notifications. Even maintenance is on just in time. Like, we used to have daily maintenance, we used to have weekly maintenance for all those utilities. Right now, there is no preventative maintenance at all. All the preventative maintenance based on system notifications. If your vibration is going high, maybe you need to graze it first. Let's see if your vibration comes down or not. If further something happening, just go and take a look. So we completely close the doors for the utility room. We have almost like 30 different equipments in utilities. We don't even go there. There is no work orders, there is no PM, nothing. So system telling us, like, what we need to do. Based on that, like, we perform that task. This is another slide, just a quick overview. With how Litmus is helping us, basically, like, as I mentioned, like, collecting the data to, like, analytics and making models and everything. So it's kind of one-stop shop for us, starting from data collection to building predictive models. So any, that's all I have.
It's excellent. Thank you.
Thank you so much.